Hello there, and welcome to the Slumber Lab, where curiosity gets cozy and science takes the scenic route to slumber. Tonight's gentle journey ventures into one of the most mysterious and controversial territories in all of science: quantum physics. But before we dive into the hidden reality of the quantum world, I'd love to know, where in the world are you watching from, and what time is it for you right now? Fitting, isn't it? A video about quantum physics, where the very act of observation changes reality itself. If you find this voyage soothing, intriguing, or just a nice way to unwind after a long day, I'd be ever so grateful if you gave the video a like and maybe subscribed. It helps this little corner of calm reach others who might need a peaceful pause from the perplexing nature of existence. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does, well, at least you'll have learned something about the strangest layer of reality before you drift off. So settle in, slow your thoughts, and let's begin. Because somewhere between the visible and invisible, between certainty and probability, lies the hidden reality of quantum physics. For most of human history, we believed the world worked like clockwork. Drop a ball, and it falls. Push an object, and it moves. Everything seemed predictable, mechanical, beautifully simple. Isaac Newton gave us equations that could tell us exactly where every planet would be 1,000 years from now. The universe felt like a grand machine, and we were merely discovering its gears and springs. But then, in the early 1900s, scientists began peering into the smallest corners of reality. They expected to find tinier versions of the same clockwork universe. Instead, they discovered something that defied every assumption about how reality should behave. They found a realm where particles could be in multiple places at once, where the act of looking at something changes what you're looking at, and where objects separated by vast distances could somehow influence each other instantaneously. This wasn't just a new branch of physics. This was a complete revolution in how we understand existence itself. The quantum world doesn't just operate by different rules, it operates by rules that seem to contradict logic itself. It's as if we discovered that underneath our familiar world of solid objects and predictable motion lies a realm of pure possibility, where reality itself is fundamentally uncertain. Imagine, if you will, that everything you thought you knew about the nature of reality was just the surface of a much deeper, much stranger ocean. The quantum world is that ocean, and we've only just begun to explore its depths. Every experiment reveals new mysteries, new impossibilities that somehow manage to be true. Because the quantum world is strange in ways that challenge our most basic intuitions about reality. It's a place where the impossible becomes routine, where the very foundations of existence seem to shift and shimmer like mirages. But here's what makes it even more remarkable. This isn't just academic curiosity. The quantum world isn't some distant realm that has nothing to do with our daily lives. Every atom in your body, every photon of light that allows you to see these words, every process that keeps your brain thinking and your heart beating, all of it is governed by quantum mechanics. The strange, impossible rules of the quantum world are what make ordinary reality possible. So tonight, as we drift through this quantum landscape together, we'll discover that the hidden reality of quantum physics isn't hidden at all. It's everywhere around us, woven into the very fabric of existence. We just never learn to see it. We'll explore how particles can exist in multiple states simultaneously, how the universe seems to know when it's being watched, and how the act of measurement creates the very reality we experience. We'll journey through the double-slit experiment, where light behaves like both a wave and a particle, depending on how we choose to observe it. And perhaps most remarkably, we'll discover how quantum mechanics doesn't just describe the behavior of tiny particles. It offers profound insights into the nature of consciousness, reality, and our place in the universe. The quantum world suggests that reality isn't something that exists independently of observation. Instead, it's something that emerges from the interaction between observer and observed, between mind and matter. This is the hidden reality of quantum physics, not just a collection of strange phenomena, but a fundamental truth about the nature of existence itself. It's a reality where consciousness and cosmos are intimately connected, where the universe is not a machine, but a living, breathing, ever-changing tapestry of possibility. So as we begin this gentle exploration together, remember that you're not just learning about abstract scientific concepts. You're discovering the deepest truths about the reality you inhabit every moment of your life. The quantum world isn't separate from your world. It is your world, seen with new eyes. Take a deep breath, let your mind relax, and prepare to have your understanding of reality gently transformed. Welcome back to the Slumber Lab, where the impossible becomes inevitable and the hidden truths of reality unfold in the gentle twilight of understanding. I'm so glad you've returned to this quiet corner where physics meets philosophy and consciousness dances with the quantum realm. In our first exploration, we discovered that the universe isn't the predictable clockwork mechanism we once imagined. Instead, we found ourselves standing at the threshold of something far more mysterious, where particles exist in multiple states until observed, where reality emerges through interaction, and where the very act of measurement shapes what we measure. Tonight, we venture deeper into this strange territory, following the threads that quantum physics has woven through the fabric of existence itself. If you're settling in for another peaceful journey through the cosmos of ideas, I'd be grateful if you gave this video a gentle like and perhaps subscribe to join our growing community of curious minds. And wherever you are in the world tonight, whatever time it is in your corner of the universe, know that you're part of something larger, a collective exploration of the deepest mysteries that surround us. Now, as we prepare to dive deeper into the quantum realm, let's begin with a question that has puzzled physicists for over a century. If quantum mechanics is so strange and counterintuitive, why don't we see its effects in our everyday world? Why doesn't your coffee cup exist in multiple states? Why can't you quantum tunnel through your bedroom wall? The answer lies in something called decoherence, and it's perhaps one of the most important concepts in modern physics that most people have never heard of. Imagine, if you will, a perfectly isolated quantum system. A single photon trapped in a mirrored box, existing in a superposition of all possible states. In this pristine environment, quantum weirdness reigns supreme. The photon can be in multiple places at once, spinning in all directions simultaneously, a ghostly probability cloud of pure potential. But the moment this system interacts with its environment, even in the slightest way, something remarkable happens. The delicate quantum coherence begins to unravel like a spider's web touched by morning dew. This process, known as decoherence, is why we live in what appears to be a classical world despite being made of quantum particles. Every interaction with the environment, every stray photon, every vibrating molecule acts like a tiny measurement, collapsing the wave function and forcing quantum systems to choose specific states. It's as if the universe itself is constantly taking snapshots, turning the fluid poetry of quantum mechanics into the prose of everyday experience. But here's where it gets fascinating. Decoherence doesn't eliminate quantum mechanics. It simply pushes it to smaller and smaller scales, shorter and shorter timescales. In the warm, noisy environment of our macroscopic world, quantum coherence typically lasts for mere femtoseconds, trillionths of a second. Your coffee cup appears solid and definite, not because it isn't quantum mechanical, but because its quantum nature is being constantly measured and collapsed by its interactions with air molecules, photons, and thermal vibrations. This discovery has revolutionized our understanding of the quantum classical boundary. It's not a sharp line, but a fuzzy transition zone where quantum effects gradually fade into classical behavior. And remarkably, scientists have learned to manipulate this boundary, creating quantum systems that maintain their coherence for longer and longer periods, even in relatively warm and noisy environments. Consider the remarkable world of quantum biology, where nature herself has learned to harness quantum effects in warm, wet, noisy biological systems. In photosynthesis, plants appear to use quantum coherence to explore multiple pathways simultaneously, finding the most efficient route for energy transfer with almost perfect efficiency. Birds may navigate using quantum entanglement in their eyes, creating a quantum compass that allows them to see magnetic fields. Even our sense of smell might rely on quantum tunneling, where molecules are identified not just by their shape, but by their vibrational quantum signatures. These discoveries suggest that the boundary between quantum and classical isn't as rigid as we once thought. Life itself seems to dance along this boundary, exploiting quantum effects where they're useful, while maintaining the stability needed for complex biological processes. It's as if evolution has been conducting quantum physics experiments for billions of years, long before humans ever conceived of such things. But perhaps the most profound implication of decoherence is what it tells us about the nature of reality itself. If quantum mechanics is fundamental, and classical physics emerges from quantum mechanics through decoherence, then in some sense, classical reality is an illusion. Not a false illusion, but an emergent one, like the way wetness emerges from H2O molecules, or the way consciousness emerges from neural activity. This brings us to one of the most contentious questions in quantum mechanics. What exactly constitutes a measurement? In the early days of quantum theory, it seemed like consciousness itself might play a special role. After all, when a physicist observes a quantum system, it collapses into a definite state. Does this mean that consciousness creates reality? This idea, sometimes called the consciousness interpretation, has captivated philosophers and mystics for decades, but most physicists today are skeptical. The modern understanding suggests that any interaction that leaves a record, any process that creates information about a quantum system, constitutes a measurement. It doesn't require a conscious observer, just an irreversible interaction with the environment. A photon hitting a detector, an electron colliding with an atom, even a dust particle scattering light. All of these can cause wave function collapse. Consciousness isn't special in this regard. It's simply one of many ways that information can be recorded and processed. Yet this raises an even deeper question. What is information, really? In quantum mechanics, information isn't just data. It's a physical quantity, as real as energy or momentum. The quantum state of a system contains all the information there is to know about that system. When decoherence occurs, this quantum information doesn't disappear. It spreads out into the environment, becoming entangled with countless other degrees of freedom until it's effectively lost to us. This perspective has led to some remarkable insights. Some physicists now argue that reality itself is made of information, that matter and energy are simply different ways of organizing and processing quantum information. In this view, the universe isn't a collection of things. It's a vast information processing system, constantly computing its own evolution through the laws of quantum mechanics. This information-theoretic view of quantum mechanics has practical implications too. It's the foundation of quantum computing, where information is processed using quantum superposition and entanglement to solve certain problems exponentially faster than classical computers. It's behind quantum cryptography, where the laws of physics themselves guarantee the security of communications. And it's opening up entirely new fields like quantum machine learning and quantum artificial intelligence. But let's pause for a moment and consider what all this means for our understanding of ourselves and our place in the universe. If reality emerges from quantum information processing, if consciousness is a pattern of information flow in neural networks, if the boundary between observer and observed is more fluid than we once thought, then perhaps we're not separate from the quantum realm at all. Perhaps we're expressions of it, temporary patterns in the vast quantum field that underlies all existence. This perspective doesn't diminish us, it elevates us. We're not just passive observers of a mechanical universe, we're active participants in the ongoing creation of reality through our interactions with the quantum field. Every measurement we make, every observation we record, every conscious experience we have contributes to the collapse of quantum possibilities into actual experiences. And here's a beautiful thought. If quantum mechanics is truly fundamental, then the entire history of the universe, from the Big Bang to this very moment, can be seen as a vast process of decoherence, of quantum possibilities gradually crystallizing into the classical reality we inhabit. The stars, the planets, life itself, consciousness, all of it emerging from the quantum foam through countless acts of measurement and observation. In this view, we're not just made of stardust, we're made of collapsed quantum possibilities. We're the universe's way of observing itself, of turning potential into actual, of creating meaning from the raw material of quantum information. It's a perspective that's both humbling and empowering, suggesting that consciousness isn't separate from the physical world, but is perhaps the physical world's most remarkable achievement. As we drift deeper into this quantum landscape, we begin to see that the strange effects we explored in our first journey aren't just curiosities or laboratory oddities. They're glimpses into the fundamental nature of reality itself, hints at a deeper level of existence where the boundaries between mind and matter, observer and observed, possible and actual, become beautifully blurred. Tonight, as you settle into sleep, remember that you're not just resting your body. You're allowing your consciousness to disengage from the constant process of decoherence, perhaps touching, however briefly, the quantum realm from which all experience emerges. In your dreams, freed from the constraints of classical logic, you might just glimpse the superposition of possibilities that underlies all existence. Sweet dreams, fellow travelers. In the quantum realm, even sleep is an adventure in consciousness, a journey through the hidden reality that physics has revealed, but that our hearts have always known. Looking back at your journey through the quantum realm, we've witnessed the extraordinary transition from the orderly, predictable universe of classical physics into the strange and wonderful world of quantum mechanics. We've explored how particles exist in superposition, dancing between multiple states until observation collapses them into reality. We've marveled at entanglement, that spooky action at a distance where particles remain mysteriously connected across vast expanses of space and time. The double-slit experiment revealed to us the fundamental duality of matter and energy, showing how the very act of measurement changes what we observe. We discovered how decoherence explains why quantum weirdness fades away at larger scales, creating the classical world we experience daily. Yet even in our familiar realm, quantum effects persist, quietly powering the technology in our pockets and the biological processes that sustain life itself. Perhaps most profoundly, we've seen how quantum physics challenges our understanding of reality itself. The role of consciousness, the nature of information, and the very fabric of existence all take on new meaning when viewed through the quantum lens. We've glimpsed how measurement doesn't just reveal reality, but actively participates in creating it, suggesting that the universe and consciousness are far more intertwined than classical physics ever imagined. The quantum world teaches us that reality emerges from potentiality, that information is fundamental, and that the act of observation bridges the gap between what could be and what is. In this view, we are not passive observers of the universe, but active participants in its ongoing creation, each measurement and observation adding another thread to the vast tapestry of existence. As we conclude this gentle exploration, remember that quantum physics isn't just about particles and waves, equations and experiments. It's about the profound mystery of existence itself, the delicate dance between mind and matter, and the beautiful uncertainty that makes our universe not just possible, but endlessly fascinating. The quantum realm reminds us that beneath the surface of everyday reality lies something far stranger and more wonderful than we might have imagined. And perhaps, in that strangeness, we find not confusion, but a deeper kind of clarity about our place in this vast, interconnected, quantum cosmos. So as you drift towards sleep tonight, consider this. You are made of quantum particles, shaped by quantum processes, embedded in a quantum universe that is still writing its own story. You are not separate from this cosmic mystery. You are part of it, a conscious observer helping to weave the very fabric of reality itself. Sweet dreams, fellow quantum traveler. Welcome to the Slumber Lab, where consciousness meets the quantum realm in the most extraordinary ways. You've journeyed with us through the foundations of quantum physics, witnessed reality bend and shift at the smallest scales, and begun to glimpse the profound implications of a universe that refuses to behave according to our everyday expectations. Tonight, we venture deeper into territories where the very nature of information, consciousness, and reality itself become beautifully entangled. What if I told you that the quantum world doesn't just exist in laboratories and theoretical equations, but pulses through every cell in your body, every thought in your mind, and every moment of your existence? What if the strange quantum phenomena we've explored aren't just curiosities of physics, but the very mechanisms through which life itself operates, thinks, and experiences reality? As you settle into this gentle exploration, perhaps with the soft glow of evening light filtering through your window, know that we're about to discover something remarkable. The quantum realm isn't separate from you, distant and abstract. It's woven into the fabric of your being in ways that are only now beginning to be understood. And these discoveries are reshaping not just our understanding of physics, but our understanding of what it means to be alive, to be conscious, to be human. Let's begin this quiet journey into the quantum foundations of life itself, where the microscopic dance of particles gives rise to the grand symphony of biology, consciousness, and perhaps even the very experience you're having right now, listening to these words in your own unique corner of the quantum universe. In the early days of quantum physics, scientists believed they were studying something exotic and removed from everyday life. Quantum effects, they assumed, were confined to the cold, isolated environments of physics laboratories, observable only when particles were stripped away from the messy, warm, wet world of living things. Biology, with its complex molecules and bustling cellular activity, seemed far too chaotic and noisy for the delicate quantum phenomena to survive. But nature, as we've learned time and again, is far more ingenious than our assumptions. In recent decades, a revolutionary field has emerged that bridges the gap between the quantum realm and the living world. Quantum biology, as it's come to be known, reveals that life doesn't just tolerate quantum effects, it harnesses them with extraordinary precision. Consider photosynthesis, the process by which plants capture sunlight and transform it into the energy that powers nearly all life on Earth. For over a century, scientists understood the basic chemistry involved, how chlorophyll molecules absorb light and trigger a cascade of reactions. But the efficiency of this process always seemed mysteriously high. Plants managed to capture and convert light energy with an effectiveness that approaches theoretical perfection, far exceeding what classical physics would predict. The answer, it turns out, lies in quantum coherence. When a photon strikes a chlorophyll molecule, it doesn't simply bounce around randomly until it finds the right chemical pathway. Instead, it exists in a quantum superposition, simultaneously exploring multiple pathways through the photosynthetic machinery. Like a quantum explorer that can walk down several paths at once, the energy finds the most efficient route through what scientists call quantum tunneling and coherent energy transfer. This isn't just theoretical speculation. Researchers have detected these quantum effects directly, using sophisticated techniques that can observe coherence lasting for surprisingly long periods, even in the warm, wet environment of living cells. The photosynthetic apparatus operates like a biological quantum computer, using superposition and entanglement to solve the complex optimization problem of energy transfer with breathtaking efficiency. But photosynthesis is just the beginning. Quantum effects appear to play crucial roles in many biological processes that were once thought to be purely classical. Take the sense of smell, for instance. The traditional lock and key model suggested that odor molecules fit into receptor sites, like keys into locks, with molecular shape determining scent. But this model couldn't explain many puzzling observations, such as why molecules with nearly identical shapes could smell completely different, or why isotopes of the same molecule could have distinct odors. Enter quantum biology. Some researchers propose that our sense of smell operates through quantum tunneling, where electrons can pass through energy barriers that would be impossible to cross classically. According to this quantum theory of olfaction, the vibrational frequencies of odor molecules, rather than just their shapes, determine how they smell. When an odor molecule binds to a receptor, electrons tunnel across it, and the efficiency of this tunneling depends on the molecule's vibrational signature. Different isotopes vibrate at different frequencies, leading to different smells, even though their shapes are nearly identical. Even more extraordinary is the growing evidence for quantum effects in avian navigation. Many birds can navigate across thousands of miles with remarkable precision, using Earth's magnetic field as a compass. But how does a robin detect something as subtle as the planet's magnetic field, which is thousands of times weaker than a typical refrigerator magnet? The answer appears to lie in quantum entanglement within the bird's eye. Certain proteins in the retina, called cryptochromes, may create pairs of quantum entangled electrons when struck by blue light. These entangled pairs are exquisitely sensitive to magnetic fields. The Earth's magnetic field subtly influences the quantum states of these electron pairs, creating patterns of activity that the bird's brain can interpret as a magnetic compass overlay on its visual field. In essence, migrating birds may literally see the magnetic field as a shimmering quantum pattern superimposed on their normal vision. These discoveries force us to reconsider the relationship between quantum physics and biology. Rather than quantum effects being fragile phenomena that disappear in biological systems, life appears to have evolved sophisticated mechanisms to create and maintain quantum coherence even in warm, noisy environments. Biological systems don't fight against quantum mechanics. They embrace it, using quantum effects to achieve capabilities that would be impossible through classical means alone. The implications extend far beyond individual biological processes. If quantum effects are integral to basic biological functions like energy transfer, sensory perception, and navigation, then quantum mechanics isn't just relevant to life, it's essential to it. The quantum realm isn't separate from the biological realm. It's the foundation upon which biology builds its most sophisticated capabilities. This realization opens up profound questions about the nature of life itself. Are living systems fundamentally quantum mechanical? Do the strange properties of superposition, entanglement, and coherence play roles in processes we haven't yet discovered? And perhaps most intriguingly, If basic biological functions rely on quantum effects, what might this mean for higher-level phenomena like consciousness, memory, and cognition? As you contemplate these ideas, perhaps feeling the quiet rhythm of your own biological processes, the steady beat of your heart, the gentle flow of your breath, consider that within each cell of your body, quantum events may be unfolding with each passing moment. The very mechanisms that allow you to see these words, to process their meaning, to feel the sensations of your body resting, may all depend on the strange and beautiful quantum dance taking place at the molecular level. We're only beginning to understand how deeply quantum mechanics is woven into the fabric of life. But one thing is becoming increasingly clear. The quantum realm isn't just the domain of physicists and their equations. It's the hidden foundation of the living world, the invisible stage upon which the drama of biology plays out, moment by quantum moment. If quantum effects permeate the biological world, from the photosynthetic machinery of plants to the navigation systems of birds, then we must ask a profound question. What role might quantum mechanics play in the most mysterious biological phenomenon of all, consciousness itself? For centuries, consciousness has remained one of the deepest puzzles of human existence. How does the 3-pound mass of tissue in our skulls give rise to the rich, subjective experience of being aware? How do electrical impulses traveling between neurons create the feeling of seeing a sunset, remembering a childhood moment, or pondering the nature of existence? And perhaps most puzzling of all, how does consciousness appear to be unified and coherent, given that the brain consists of billions of separate neurons? Some researchers have begun to explore whether quantum mechanics might provide answers to these ancient questions. While the field of quantum consciousness remains highly speculative and often controversial, the basic idea is compelling. If quantum effects can create coherent, integrated behavior in biological systems, might they also explain the coherent, integrated nature of conscious experience? One of the most intriguing proposals comes from physicist Roger Penrose and anesthesiologist Stuart Hameroff, who suggest that consciousness arises from quantum processes within the microtubules that form the structural skeleton of neurons. Microtubules are tiny protein structures that maintain the shape of cells and transport materials within them. Penrose and Hameroff propose that these structures could support quantum coherence and perform quantum computations that give rise to conscious awareness. According to their theory, consciousness doesn't emerge from the classical firing patterns of neurons, but from quantum processes occurring within the microtubules of many neurons simultaneously. These quantum processes could create a coherent quantum state spanning large regions of the brain, providing a physical basis for the unified nature of conscious experience. While this theory remains highly debated, it raises fascinating questions about the nature of consciousness and its relationship to quantum mechanics. If consciousness does involve quantum effects, it would suggest that the act of being aware is fundamentally connected to the deepest levels of physical reality. Your thoughts, emotions, and perceptions might not be separate from the quantum realm, but expressions of it. Other researchers have explored different connections between quantum mechanics and consciousness. Some suggest that quantum indeterminacy might provide the physical basis for free will, allowing conscious decisions to influence brain activity in ways that aren't completely determined by prior physical states. Others propose that quantum entanglement might explain how different regions of the brain coordinate to create unified conscious experiences. Even more speculative ideas venture into territory that challenges our basic assumptions about the relationship between mind and matter. If consciousness involves quantum effects, and if quantum mechanics reveals the fundamental interconnectedness of all things, might consciousness itself be more fundamental than we typically assume? Some interpretations of quantum mechanics, such as the participatory universe concept, suggest that consciousness plays an active role in shaping physical reality through the process of observation and measurement. These ideas remain at the frontier of scientific inquiry, more philosophical exploration than established fact. The brain is an incredibly complex system, And we're still far from understanding how classical neural processes give rise to consciousness, let alone quantum ones. The warm, wet environment of the brain seems hostile to the delicate quantum effects that might be required for quantum theories of consciousness to work. Yet the discoveries in quantum biology suggest that we shouldn't be too quick to dismiss the possibility of quantum effects in neural systems. If plants can maintain quantum coherence for photosynthesis and birds can use quantum entanglement for navigation, perhaps the brain has evolved mechanisms to harness quantum effects for information processing and conscious experience. Recent research has begun to find evidence for quantum-like effects in certain aspects of brain function. Studies have detected quantum coherence in some biological molecules found in neurons, and researchers have observed behavior in neural networks that resembles quantum computation. While these findings don't prove that consciousness is quantum mechanical, they suggest that the brain might be more quantum than we previously assumed. Whether or not consciousness ultimately proves to involve quantum effects, exploring these connections forces us to think more deeply about the nature of awareness itself. Consciousness involves integration, binding together vast amounts of information into unified experiences. It involves creativity, generating novel thoughts and ideas that seem to emerge from nothing. It involves intentionality, the mysterious ability of thoughts to be about things in the world. These features of consciousness, integration, creativity, and intentionality share intriguing parallels with quantum phenomena. Quantum systems can exist in superposed states that integrate multiple possibilities simultaneously. Quantum processes can generate truly random events, providing a potential source of novelty and creativity. And the quantum measurement process involves a kind of intentionality, where the act of observation determines which possibility becomes actual. As you experience the flow of your own consciousness right now, the stream of thoughts, sensations, and awareness that constitutes your inner life, consider the possibility that this experience might be more deeply connected to the quantum realm than you ever imagined. The very fact that you can contemplate these ideas, that you can hold multiple concepts in mind simultaneously and weave them together into understanding, might reflect quantum processes occurring within the neural networks of your brain. We may never fully resolve the question of quantum consciousness, but exploring it opens up new ways of thinking about who we are and our place in the universe. If consciousness does involve quantum effects, then every moment of awareness represents a quantum event, a collapse of possibilities into actuality, a creative act that participates in the ongoing evolution of reality itself. In this view, consciousness isn't just a passive observer of the quantum world, it's an active participant, helping to shape the very reality it observes. And you, as a conscious being, are not separate from the quantum universe, but intimately entangled with it. Your thoughts and experiences woven into the fabric of existence at the most fundamental level. As we contemplate the possible quantum nature of consciousness, we encounter one of the most profound and unsettling implications of quantum mechanics, the role of the observer in shaping reality. Throughout our exploration of the quantum realm, we've seen how the act of measurement appears to transform quantum possibilities into definite outcomes. But what if this relationship between observation and reality extends far beyond the physics laboratory? What if consciousness itself plays a fundamental role in the very existence of the physical world? This idea strikes at the heart of our everyday assumptions about reality. We typically think of the world as existing independently of our awareness of it. Mountains, oceans, stars, and galaxies seem to exist whether anyone observes them or not. But quantum mechanics suggests a more complex and interactive relationship between consciousness and reality, one where the boundary between observer and observed becomes surprisingly fluid. The measurement problem in quantum mechanics forces us to confront this issue directly. According to the mathematics of quantum theory, quantum systems exist in superposition until they're measured. But what constitutes a measurement? Is it the interaction with a detector, the registration of information, or something more subtle involving conscious awareness? Some interpretations of quantum mechanics suggest that consciousness plays a special role in the measurement process. In this view, quantum superpositions persist until they encounter a conscious observer, at which point the wave function collapses and definite outcomes emerge. This would mean that consciousness doesn't just observe reality, it participates in creating it through the very act of observation. This interpretation leads to startling implications. If consciousness is required to collapse quantum wave functions, then the existence of definite physical properties might depend on the presence of conscious observers. The moon might not have a definite position until someone looks at it. A tree falling in an empty forest might remain in a superposition of fallen and standing states until a conscious being observes the result. While these ideas might seem absurd, they're taken seriously by some physicists and philosophers. The participatory universe concept, developed by physicist John Wheeler, suggests that we live in a universe where observers are participants rather than passive spectators. In Wheeler's words, we exist in a participatory universe where the act of observation helps bring reality into being. Wheeler illustrated this concept with his famous delayed choice thought experiments, which have since been realized in actual laboratory tests. These experiments suggest that the choice of how to observe a quantum system can retroactively determine the system's past behavior. In some sense, present observations can influence past events, creating a kind of feedback loop between consciousness and reality that extends across time. Even more provocatively, Wheeler proposed that the universe might be structured as a self-observing system, where conscious observers emerge from the universe and then participate in defining the very reality from which they arose. In this view, consciousness and cosmos are locked in a cosmic feedback loop, each giving rise to the other in an endless dance of creation and observation. These ideas venture into territory that challenges our most basic assumptions about the nature of existence. If consciousness plays a fundamental role in shaping reality, then the emergence of conscious beings in the universe represents more than just a biological accident. It might be a necessary feature of reality itself, required for the universe to achieve definite form and structure. This perspective finds resonance in various philosophical and spiritual traditions that have long suggested the primacy of consciousness in the nature of reality. But quantum mechanics provides a potential scientific framework for understanding how consciousness and reality might be fundamentally interconnected, not just philosophically, but physically. The implications extend beyond physics into questions about the nature of knowledge, truth, and existence itself. If consciousness participates in creating reality through observation, then the scientific enterprise of studying the natural world becomes a creative act rather than merely a discovery process. Scientists don't just uncover pre-existing truths about nature. They participate in bringing those truths into being through their observations and measurements. This doesn't mean that reality is arbitrary, or that we can simply think things into existence through wishful thinking. Quantum mechanics still operates according to precise mathematical laws, and the probabilities of different outcomes are determined by the wave function. But within the constraints of these quantum laws, consciousness might play a role in selecting which possibilities become actual. The relationship between consciousness and quantum reality also raises profound questions about the nature of time and causality. If present observations can influence past events, as suggested by delayed choice experiments, then the traditional view of time as a linear sequence of cause and effect becomes problematic. Instead, we might need to think of time as a more complex structure where past, present, and future are interconnected through quantum correlations. As you contemplate these ideas, consider your own role as a conscious observer in this quantum universe. Every moment of awareness, every act of attention, every conscious observation you make might be participating in the ongoing creation of reality. The very fact that you're aware of these words, processing their meaning, and perhaps questioning their implications could be contributing to the collapse of quantum possibilities into definite actualities. This perspective transforms the experience of consciousness from a passive reception of sensory information to an active participation in the unfolding of reality. You're not just witnessing the world, you're helping to create it through the very act of conscious observation. Your thoughts, perceptions, and awareness are not separate from the physical world, but intimately entangled with it at the quantum level. Whether or not consciousness ultimately proves to play such a fundamental role in quantum mechanics, exploring these possibilities expands our understanding of what it means to be conscious beings in a quantum universe. We are not isolated observers looking at reality from the outside, but participants embedded within the very fabric of existence, our consciousness woven into the quantum tapestry of space, time, and matter. In this view, every moment of awareness is a creative act, a participation in the ongoing evolution of the cosmos, a quantum event that helps shape the reality we inhabit. And perhaps, in the gentle quiet of contemplation, we can sense this deep connection between our inner experience and the fundamental structure of existence itself. Having journeyed through the quantum foundations of life and consciousness, we arrive at perhaps the most practical and immediate question. How might understanding quantum physics change the way we live, think, and relate to the world around us? The implications of quantum mechanics extend far beyond abstract physics and into the very heart of human experience, offering new perspectives on uncertainty, interconnectedness, and the nature of reality itself. One of the most profound lessons of quantum mechanics is the fundamental role of uncertainty in the fabric of reality. Heisenberg's uncertainty principle tells us that certain pairs of properties cannot be simultaneously measured with perfect precision. This isn't just a limitation of our measuring instruments, it's a basic feature of reality itself. At the quantum level, the universe is inherently uncertain, probabilistic, and open-ended. This quantum uncertainty challenges our classical desire for complete predictability and control. We often struggle with uncertainty in our lives, seeking to know the future, to understand all the variables, to control outcomes. But quantum mechanics suggests that uncertainty isn't a flaw in the system, it's an essential feature. The universe is creative precisely because it's not completely determined. The future remains genuinely open, full of possibilities that haven't yet been realized. Embracing this quantum perspective on uncertainty can be profoundly liberating. Instead of viewing uncertainty as something to be eliminated or feared, we can recognize it as the space where creativity, growth, and genuine novelty emerge. The uncertain future isn't a problem to be solved, but a canvas of possibilities to be explored. Quantum mechanics also reveals the deep interconnectedness of all things through phenomena like entanglement. Once quantum systems interact, they become correlated in ways that transcend classical notions of separateness. The measurement of one particle instantly influences the state of its entangled partner, regardless of the distance between them. This quantum interconnectedness suggests that the universe is not a collection of separate objects, but a seamless web of relationships and correlations. This insight has profound implications for how we understand ourselves and our relationships with others and the natural world. If quantum entanglement is a fundamental feature of reality, then our sense of separation from others and from nature might be, in some deep sense, an illusion. We are not isolated individuals struggling alone in an indifferent universe, but interconnected beings embedded within a web of quantum relationships that spans the cosmos. The quantum perspective on information also offers new ways of thinking about knowledge, learning, and understanding. In classical physics, information is something that describes systems from the outside. But in quantum mechanics, information is more fundamental. The state of a quantum system is information, and the evolution of quantum systems can be understood as information processing. Some physicists even suggest that reality itself might be made of information, with matter and energy being particular ways that information manifests. This view suggests that consciousness, which involves the processing and integration of information, might be more fundamental to reality than we typically assume. If the universe is essentially informational, then conscious beings who can process, understand, and create information are not mere accidents, but expressions of the universe's deepest nature. The quantum measurement process also offers insights into the nature of knowledge and reality. The act of measurement doesn't just reveal pre-existing properties, it participates in creating the reality being measured. This suggests that knowledge is not just passive reception of information about an independent reality, but active participation in the ongoing creation of that reality. This participatory view of knowledge has implications for how we approach learning, science, and understanding. We are not just passive observers trying to figure out a fixed reality, but active participants helping to shape the reality we study. This perspective can make the pursuit of knowledge feel more meaningful and creative, transforming learning from mere information absorption into active participation in the unfolding of understanding. The quantum world also challenges our classical notions of time and causality. Quantum correlations can span space instantaneously, and some quantum experiments suggest that present choices can influence past events. This quantum view of time is more fluid and interconnected than our everyday experience suggests, with past, present, and future linked through quantum relationships that transcend simple cause and effect. This perspective can change how we think about memory, decision-making, and the flow of experience. If time is more interconnected than we assume, then our present choices might have broader implications than we realize, rippling not just forward into the future, but backward into the past, and outward into the web of quantum correlations that connect us to the larger universe. Perhaps most importantly, quantum mechanics reveals a universe that is fundamentally creative and open-ended. The collapse of the wave function represents genuine creativity, the emergence of something new from the realm of pure possibility. Every quantum measurement is a creative act, bringing new realities into being from the infinite potential of the quantum realm. This quantum creativity is not just a feature of microscopic particles, but potentially extends to all levels of reality, including consciousness and life. If consciousness involves quantum processes, then every moment of awareness might be a creative act, participating in the ongoing evolution of reality itself. Your thoughts, perceptions, and choices might not just be responses to a fixed reality, but contributions to the creative unfolding of existence. Living with quantum awareness means embracing uncertainty as creative potential, recognizing interconnectedness as fundamental reality, and understanding consciousness as active participation in the cosmos rather than passive observation of it. It means appreciating that you are not separate from the quantum universe, but intimately entangled with it, your very existence woven into the fabric of quantum reality. As you rest in this understanding, perhaps feeling the quiet rhythm of your breath and the gentle awareness of your own being, consider that each moment of consciousness might be a quantum event, a creative collapse of possibilities into actuality, a participation in the ongoing dance of existence that spans from the smallest quantum scales to the vastest cosmic structures. In this quantum view, you are not just in the universe, you are the universe becoming conscious of itself, reality awakening to its own nature through the miracle of awareness. We've reached the threshold where the quantum realm whispers its most profound secret, where the very foundations of reality blur into something far stranger than fiction. What we've discovered through our journey into quantum mechanics isn't just a collection of peculiar phenomena, but a fundamental reimagining of existence itself. The classical world promised us certainty, predictability, a universe that ticked along like clockwork. But quantum physics has revealed something far more mysterious and beautiful. At the deepest level, reality doesn't consist of solid, definite things moving through empty space. Instead, it's a shimmering tapestry of possibilities, a dance of probabilities where observation itself becomes an act of creation. Think about what this means for a moment. The electron doesn't have a definite position until we look for it. The photon doesn't choose its path until we force it to decide. The quantum system exists in multiple states simultaneously until the moment of measurement collapses it into our everyday reality. This isn't just strange physics, it's a fundamental statement about the nature of existence itself. What emerges from this quantum landscape is even more remarkable. Entanglement shows us that particles can be connected across vast distances, sharing information instantaneously in ways that Einstein called spooky action at a distance. These aren't separate objects bumping into each other like billiard balls, but aspects of a deeper, interconnected whole. The universe begins to look less like a machine and more like a living, breathing organism, where every part knows about every other part. But perhaps the most profound realization is how consciousness fits into this picture. The measurement problem in quantum mechanics suggests that conscious observation plays a fundamental role in shaping reality. We're not passive observers watching a predetermined show unfold. We're active participants in the very creation of the world we experience. Every measurement, every observation, every moment of awareness potentially influences the quantum processes that underlie all physical phenomena. This participatory universe challenges everything we thought we knew about our place in existence. We're not separate from the cosmos, looking in from the outside. We're woven into its very fabric, our consciousness intimately connected to the quantum processes that generate reality moment by moment. The boundary between observer and observed, between mind and matter, begins to dissolve. The implications stretch far beyond physics. If consciousness and quantum mechanics are indeed connected, then perhaps our thoughts, intentions, and awareness have a more direct relationship with the physical world than we ever imagined. The placebo effect, the power of intention, the mysterious workings of intuition, all of these phenomena that science has struggled to explain might find their foundation in the quantum realm. Even life itself appears to harness quantum effects. Photosynthesis, the process that powers most of life on Earth, uses quantum coherence to achieve near-perfect efficiency. Birds navigate using quantum entanglement in their cellular compasses. Our own brains might process information through quantum mechanisms that we're only beginning to understand. Life doesn't just exist despite quantum weirdness, it thrives because of it. What we're witnessing is the emergence of a new worldview, one where uncertainty isn't a limitation, but a fundamental feature of existence, where randomness isn't chaos, but creativity, where the act of observation isn't passive, but participatory. This quantum reality suggests that consciousness, information, and physical processes are far more intimately connected than classical physics ever imagined. As we drift deeper into understanding this quantum cosmos, we find ourselves not in a cold, mechanical universe, but in something far more mysterious and alive. A reality where possibilities exist before actualities, where consciousness and cosmos dance together in an eternal creative process, where the very act of being aware contributes to the ongoing creation of existence itself. The quantum world invites us to see ourselves not as isolated islands of consciousness in a vast, indifferent ocean, but as integral threads in a cosmic tapestry of meaning and connection. Every thought, every observation, every moment of awareness participates in the grand symphony of quantum creativity that we call reality. In this strange and beautiful quantum universe, we are both the music and the musicians, both the dream and the dreamers, both the question and the answer. And perhaps, in the gentle quantum fluctuations that permeate the void, in the entangled connections that transcend space and time, in the mysterious marriage of consciousness and cosmos, we glimpse something that classical physics could never have revealed. We are home. We have always been home. We are the universe becoming aware of itself, one quantum measurement at a time, one conscious observation at a time, one moment of wonder at a time. We've journeyed through the intricate architecture of reality, from quantum superposition to biological quantum effects, from the observer's role in shaping existence to the participatory nature of consciousness itself. Now, as we drift toward the edge of understanding, we arrive at perhaps the most profound realization of all. Quantum physics doesn't just describe reality, it reveals that reality itself might be far stranger, far more alive, and far more conscious than we ever dared imagine. Consider this: every quantum measurement, every collapse of possibility into actuality, every entangled connection across the cosmos represents something more than mere physics. It represents the universe becoming aware of itself. Each observation is a moment of cosmic self-recognition, a whisper of consciousness, acknowledging its own existence through the very act of measurement. The implications are staggering. If consciousness plays a fundamental role in quantum mechanics, if observation shapes reality at its most basic level, then we are not passive observers of the universe. We are active participants in its creation. Every moment of awareness, every act of observation, every conscious choice ripples through the quantum substrate of existence, contributing to the ongoing story the universe tells about itself. This isn't mere poetry, it's supported by the mathematics. The quantum Zeno effect shows that frequent observation can literally freeze quantum evolution. Quantum entanglement demonstrates instantaneous connections that transcend space and time. The measurement problem reveals that reality remains probabilistic until consciousness collapses it into definite form. These aren't anomalies to be explained away. They're clues pointing towards something magnificent. What if consciousness isn't something that emerged from complex arrangements of matter, but rather something fundamental to the quantum nature of reality itself? What if every quantum system, every particle, every field carries within it some spark of proto-consciousness? This isn't mysticism, it's a serious consideration in fields like quantum biology and consciousness studies, where researchers find quantum effects operating in the warm, wet environment of living systems. The photosynthesis in the leaf outside your window, the navigation system of migrating birds, the very thoughts forming in your mind as you contemplate these words. All of these processes appear to harness quantum coherence in ways that classical physics said should be impossible. Life doesn't just tolerate quantum effects, it orchestrates them, conducts them, uses them to create the symphony of existence. And perhaps most remarkably, quantum physics suggests that the future might influence the past just as much as the past influences the future. In quantum retrocausality experiments, measurements made today seem to retroactively determine the properties of particles in the past. Time itself becomes fluid, malleable, responsive to consciousness and choice. This paints a picture of a universe that is not mechanical but organic, not predetermined but creative, not separate from consciousness but intimately woven with it. A universe where every quantum interaction is both a calculation and a choice, where information and awareness dance together at the deepest levels of reality. We are not accidents in an indifferent cosmos. We are the universe coming to know itself through quantum eyes. Every conscious moment participates in the grand experiment of existence, each observation adding another thread to the infinite tapestry of what is real. In a very real sense, consciousness and cosmos are partners in an eternal dance of creation and discovery. As you drift towards sleep tonight, remember that your very awareness is part of this cosmic symphony. The quantum fields that make up your body are entangled with the quantum fields of distant stars. The consciousness that contemplates these mysteries is itself woven into the fabric of reality at its most fundamental level. You are not separate from the quantum realm. You are a conscious expression of it. Your thoughts, dreams, and awareness are quantum processes, participating in the universe's ongoing effort to understand itself. In every moment of conscious experience, you contribute to the cosmic story, adding your unique perspective to the infinite conversation between mind and matter, between possibility and actuality, between what was, what is, and what might yet become. The quantum universe is not just a place we inhabit. It's a conversation we're part of, a story we're helping to write, a dream we're dreaming together. And in that recognition, perhaps we find not just understanding, but wonder. Not just knowledge, but awe. Not just explanations, but an invitation to participate more consciously in the magnificent, mysterious, endlessly creative dance of existence itself. Sleep well, fellow quantum being. Tomorrow, the universe will continue its conversation with itself through your eyes, your thoughts, your consciousness. We stand at the threshold of something extraordinary. We've journeyed through the classical realm, where particles follow predictable paths, where cause and effect march in orderly succession, where reality appears solid and dependable. But now we must descend deeper into the quantum depths where the very foundations of existence become fluid, where observation itself shapes reality, and where the boundary between the observer and the observed begins to dissolve. Here, in this strange quantum landscape, the rules change completely. Particles exist in multiple states simultaneously until the moment of measurement. Information can travel instantaneously across vast distances through entanglement. The act of looking at something fundamentally alters what we're looking at. These aren't just curious laboratory phenomena, they're hints that consciousness itself might be woven into the very fabric of reality. Consider for a moment the profound implications of what quantum physics reveals. When we observe a quantum system, we don't simply discover its properties, we participate in bringing those properties into existence. The universe, at its most fundamental level, seems to be less like a machine running independently of observers and more like an ongoing conversation between consciousness and possibility. This participatory nature of quantum reality suggests something remarkable about our place in the cosmos. We are not merely passive witnesses to an objective reality unfolding around us. Instead, we appear to be active co-creators in the dance of existence itself. Every measurement, every observation, every moment of conscious awareness contributes to the ongoing creation of the world we experience. The quantum realm reveals that information, not matter, might be the true substrate of reality. When quantum systems become entangled, they share information instantaneously, regardless of the distance separating them. This quantum information doesn't travel through space in the conventional sense. It simply exists as a fundamental feature of how reality is structured. The universe begins to look less like a collection of separate objects and more like a unified information processing system. But quantum mechanics doesn't operate in isolation from the biological world we inhabit. In fact, recent discoveries suggest that life itself has learned to harness quantum effects with remarkable sophistication. Photosynthesis, the process that sustains most life on Earth, appears to use quantum coherence to achieve near-perfect efficiency in energy transfer. Birds navigating across continents may rely on quantum entanglement in their cellular compass systems. Even our sense of smell might depend on quantum tunneling effects that allow molecules to be identified by their vibrational signatures. These quantum biological processes hint at something profound. Life doesn't simply exist within the quantum realm. It has evolved to dance with quantum uncertainty, to extract order from quantum chaos, to find coherence within quantum superposition. We are quantum beings living in a quantum universe, yet most of the time we remain unconscious of this deeper reality. The implications extend even further when we consider consciousness itself. Some researchers propose that consciousness might emerge from quantum processes within the brain's microtubules, creating a bridge between the quantum and classical worlds. Others suggest that consciousness is fundamental to the universe itself, not something that emerges from complex arrangements of matter, but rather the ground from which matter itself emerges. This perspective transforms our understanding of who and what we are. If consciousness is indeed fundamental, then we are not accidental byproducts of a meaningless universe. Instead, we are expressions of the universe's own capacity for self-awareness, temporary focal points through which the cosmos experiences itself. The observer and the observed, the knower and the known, the dreamer and the dream, all reveal themselves as aspects of a single unified reality. The quantum world also reveals the deep interconnectedness of all things. Quantum entanglement shows us that separation is, in many ways, an illusion. When particles become entangled, they remain connected regardless of the space between them. Changes to one instantaneously affect the other, suggesting that beneath the apparent separateness of objects lies a fundamental unity. This quantum interconnectedness might extend far beyond individual particles. Some theories suggest that all matter in the universe may be entangled to some degree, creating a cosmic web of instantaneous correlation. If this is true, then every action, every thought, every moment of awareness sends ripples through the quantum field that connects all things. We are not isolated individuals struggling alone in an indifferent cosmos, but rather notes in a vast cosmic symphony, each contributing to the harmony of the whole. The uncertainty principle, far from being a limitation of our knowledge, might be a fundamental feature of how reality creates itself. Uncertainty at the quantum level allows for genuine novelty, for the emergence of the unexpected, for the spontaneous arising of new possibilities. Without quantum uncertainty, the universe would be perfectly deterministic, frozen in the amber of absolute predictability. It is precisely because the quantum realm is uncertain that creativity, evolution, and consciousness become possible. This quantum creativity extends into our own lives in ways we're only beginning to understand. Our brains, operating at the intersection of quantum and classical physics, might be quantum computers of extraordinary sophistication. Every thought, every decision, every moment of insight might emerge from quantum processes that allow mind to interface directly with the fundamental information structure of reality. The measurement problem in quantum mechanics takes on new meaning when viewed from this perspective. The question isn't just how quantum superpositions collapse into definite states, but how consciousness participates in this collapse. Every moment of awareness, every act of observation, every decision we make might be moments when the quantum field of infinite possibilities crystallizes into the specific reality we experience. This suggests that we have far more creative power than we typically realize. We are not simply responding to a pre-existing reality, We are participating in the ongoing creation of reality itself. The choices we make, the attention we pay, the consciousness we bring to each moment, all contribute to shaping the world we experience and the world we leave for future generations. The quantum realm also reveals time itself to be far more mysterious than our everyday experience suggests. Quantum effects can appear to violate our normal understanding of cause and effect, with quantum influences seeming to propagate backward through time. The future might influence the past just as much as the past influences the future. Linear time, like objective reality, might be an emergent property of deeper, more fundamental processes that operate outside our normal temporal experience. This temporal fluidity opens up extraordinary possibilities for understanding consciousness and its relationship to time. Perhaps consciousness doesn't simply exist within time, but participates in the creation of time itself. Our memories of the past and our anticipations of the future might be more than passive recordings and projections. They might be active contributions to the ongoing weaving of the temporal fabric of reality. As we explore these quantum depths, we begin to see that the boundaries we normally take for granted between self and world, between mind and matter, between past and future, between the possible and the actual, are far more fluid than they appear. The quantum realm reveals reality to be more like a verb than a noun, more like a process than a thing, more like a dance than a machine. This quantum dance is not chaotic or random, despite its inherent uncertainty. Instead, it appears to be guided by deep principles of coherence, correlation, and creative emergence. The quantum field seems to have an inherent tendency toward greater complexity, greater consciousness, greater beauty. We are not witnessing the random interactions of meaningless particles, but rather the creative unfolding of a universe that appears to be evolving toward ever greater awareness of itself. In this quantum worldview, science and spirituality begin to converge. The mystical insight that all is one finds its reflection in quantum entanglement. The spiritual understanding that consciousness is fundamental aligns with interpretations of quantum mechanics that place the observer at the center of reality. The ancient wisdom that we are all connected resonates with the quantum revelation that separation is largely illusory. We are living in an extraordinary time when the deepest insights of human wisdom traditions are finding unexpected validation in the most precise investigations of modern physics. The quantum realm is not just revealing the fundamental nature of matter and energy, it is offering us a new understanding of our own nature and our place in the cosmic story. As we continue to explore these quantum mysteries, we are not just advancing scientific knowledge, we are participating in the universe's ongoing journey of self-discovery. Each new insight into quantum reality is simultaneously an insight into the nature of consciousness, of creativity, of the deep interconnectedness that binds all things together in the magnificent dance of existence. The quantum world invites us to see ourselves not as separate beings struggling to survive in an indifferent universe, but as conscious expressions of the cosmos itself, each playing our unique part in the grand symphony of creation. Picture this. You're lying in bed, the world around you has grown quiet, and your mind begins that familiar drift towards sleep. But somewhere in the depths of your consciousness, something extraordinary is stirring. Not the ordinary thoughts of the day, not the simple memories replaying themselves, but something far more profound. Something that challenges everything you think you know about reality itself. Welcome back to the Slumber Lab, where we explore the hidden mysteries of existence through the gentle lens of drowsiness. Tonight, we're venturing into territory that might sound like science fiction, but is actually cutting-edge science. We're talking about quantum consciousness, the possibility that the very fabric of reality, the strange world of quantum mechanics, might be intimately connected to the most mysterious phenomenon of all, your awareness, your thoughts, your sense of self. Now you might be wondering, what does quantum physics have to do with consciousness? After all, one deals with particles smaller than atoms, while the other involves the rich inner world of human experience. But what if I told you that some of the world's most brilliant scientists believe these two mysteries might actually be the same mystery, viewed from different angles? Here's where things get beautifully strange. Throughout our previous explorations in this series, we've seen how quantum mechanics reveals a universe far weirder than our everyday experience suggests. We've discovered particles that exist in multiple states simultaneously, that become entangled across vast distances, that seem to respond to the very act of observation. But perhaps the most puzzling aspect of all this quantum strangeness is that last point. The role of observation, the role of measurement, the role of consciousness itself in determining what becomes real. You see, in the quantum world, particles don't have definite properties until they're observed. An electron doesn't have a specific location until someone or something measures it. A photon doesn't choose which path to take through a double-slit experiment until a detector forces it to decide. This suggests something remarkable and unsettling. Consciousness might not just be along for the ride in this universe. It might be actively participating in creating the reality we experience. But let's start gently, as we always do. Let's begin with a simple question that isn't simple at all. What is consciousness? You experience it every moment you're awake, this continuous stream of thoughts, sensations, emotions, and awareness. Yet despite being the most intimate aspect of your existence, consciousness remains one of the deepest puzzles in science. We can map the brain, trace neural pathways, measure electrical activity, but we still can't explain why there's an inner experience at all. Why isn't the brain just a biological computer processing information without any accompanying sense of what it feels like to be you? This is what philosophers call the hard problem of consciousness. We can explain the easy problems, how the brain processes information, stores memories, controls behavior, but explaining why there's a subjective experience, why there's something it's like to be conscious, that's where science has traditionally stumbled. Until now, perhaps, some researchers are beginning to wonder if consciousness isn't just something that emerges from complex brain activity, but something far more fundamental, something woven into the very fabric of reality itself, something quantum. Consider this possibility. What if consciousness isn't produced by the brain, but rather something that the brain tunes into, like a radio receiving signals from across the cosmos? What if the strange, probabilistic nature of quantum mechanics isn't just a description of how particles behave, but a description of how reality itself is constantly being created and recreated through conscious observation? This isn't mere speculation. Serious scientists are exploring these ideas, and their research is revealing connections between consciousness and quantum mechanics that are both profound and perplexing. We're discovering that the brain might not just be a classical computer made of biological parts, but a quantum system capable of processing information in ways that classical physics cannot explain. Tonight, we'll explore how quantum effects might be at work in your neurons, how consciousness might influence physical reality, and how the very act of thinking might be connected to the deepest structures of the universe. We'll journey through theories that suggest your mind is not separate from the quantum realm, but intimately entangled with it. We'll discover how some of the greatest mysteries of consciousness, from the binding problem to the nature of free will, might find their answers in the strange world of quantum superposition and entanglement. We'll explore how the measurement problem in quantum mechanics might actually be solved by understanding the role of consciousness in collapsing quantum states into definite realities. And perhaps most remarkably, we'll see how this quantum view of consciousness suggests that you are not just an observer of reality, but an active participant in its creation. Every thought, every decision, every moment of awareness might be a quantum event that helps shape the universe itself. This is a journey that bridges the gap between the scientific and the spiritual, between the measurable and the mysterious. It's a story that suggests consciousness is not something that happens in the universe, but something the universe does. It's a vision of reality where mind and matter are not separate things, but different aspects of a deeper, more fundamental unity. So as you settle into this exploration, as your conscious mind prepares to encounter ideas that challenge its own nature, remember that you're not just learning about consciousness and quantum mechanics, you're experiencing them. Every thought you have as you listen to these words, every moment of understanding that arises, every flash of insight or wonder might itself be a quantum event, a moment where consciousness and cosmos dance together in the eternal choreography of existence. The boundary between observer and observed, between mind and matter, between the quantum realm and everyday experience is about to become beautifully blurred. Here we find ourselves floating in the profound depths of quantum reality, where the very fabric of existence reveals its most intimate secrets. We've journeyed through the strange landscape of superposition and entanglement, witnessed the observer effect reshape reality before our eyes, and discovered that consciousness itself may be the hidden architect of the universe. Now, as we drift toward the culmination of our exploration, a final revelation awaits us in the quantum realm. The question that has haunted physicists for nearly a century whispers to us from the depths of quantum theory. What happens when we truly understand that reality is not fixed, not predetermined, but emerges from an infinite sea of possibilities through the very act of observation? The answer, dear traveler, is both humbling and magnificent. We discover that we are not merely witnesses to the cosmic dance, but active participants in its choreography. Consider for a moment the profound implications of what we've uncovered. In the quantum world, particles exist in multiple states simultaneously until the moment of observation collapses them into a single reality. This isn't just a quirk of subatomic physics. It's a fundamental principle that extends through every level of existence. The photons streaming from distant stars, the electrons dancing in your neurons, the very atoms that compose your being, all exist in this realm of infinite possibility until consciousness intervenes to select one thread from the vast tapestry of potential. But here's where our journey takes its most remarkable turn. Recent experiments in quantum biology have revealed that living systems, from the simplest bacteria to the most complex human brains, have evolved to harness quantum effects for their most crucial functions. Photosynthesis, the process that powers nearly all life on Earth, operates through quantum coherence, maintaining superposition states even in the warm, noisy environment of a living cell. Birds navigate using quantum entanglement in their cellular compass systems. Even the process of smell may depend on quantum tunneling effects in our olfactory receptors. We are not separate from the quantum realm. We are quantum beings, evolved to dance with uncertainty itself. Every thought, every decision, every moment of awareness may be a quantum measurement, collapsing waves of possibility into the reality we experience. The observer effect isn't something that happens to us, it is us. We are the universe observing itself, consciousness arising from the cosmic process of measurement and collapse. This realization transforms our understanding of free will, determinism, and the nature of choice itself. If reality emerges from quantum possibilities through conscious observation, then perhaps our choices don't simply select from predetermined options, but actually participate in the creation of reality. We become co-creators with the universe, our consciousness interacting with the quantum field to manifest the world we experience. The implications ripple through every aspect of human existence. In quantum field theory, Particles are understood as excitations in underlying fields that permeate all of space. These fields are not empty voids, but dynamic, fluctuating foundations of reality. The vacuum itself seethes with virtual particles, constantly appearing and disappearing in a cosmic dance of creation and annihilation. We exist not as isolated objects, but as patterns of information, waves of possibility expressing themselves through the medium of consciousness. Even time, that most fundamental dimension of our experience, reveals its quantum nature. In quantum mechanics, the arrow of time emerges from the process of measurement itself. The past becomes fixed through observation, while the future remains a superposition of possibilities waiting to be collapsed into actuality. We exist at the boundary between the determined and the undetermined, between what has been observed and what remains in quantum superposition. This quantum perspective offers a profound shift in how we relate to uncertainty and change. Rather than seeing uncertainty as a limitation or flaw in our knowledge, we can understand it as the very source of creativity and novelty in the universe. Quantum indeterminacy isn't a bug in the cosmic code. It's a feature that allows for genuine novelty, for the emergence of the unexpected, for the universe to surprise itself. The entanglement we've explored extends beyond individual particles to encompass entire systems, creating what physicists call the quantum web. Every interaction, every observation, every moment of consciousness creates threads of connection that span across space and time. We are not isolated observers, but integral parts of a vast interconnected quantum system. When we observe a distant star, we become entangled with photons that have traveled for millions of years to reach us. In that moment of observation, we participate in a cosmic conversation that transcends the boundaries of space and time. This interconnectedness suggests that consciousness itself may be a fundamental feature of the universe, not something that emerges from complex arrangements of matter, but something that matter emerges from. The hard problem of consciousness, the mystery of how subjective experience arises from objective physical processes, may dissolve when we realize that consciousness and quantum measurement are intimately connected phenomena. As we float here in the quantum realm, we can sense the profound mystery that remains. Science has revealed the mechanisms of quantum behavior, but the deeper question of why the universe is structured this way, why consciousness and quantum measurement are so intimately connected, remains beautifully open. Perhaps this is as it should be. Perhaps the universe maintains its capacity for wonder by keeping some secrets, by ensuring that no matter how much we discover, mystery remains at the heart of existence. The quantum world whispers to us of deeper truths about the nature of reality, consciousness, and our place in the cosmic order. It suggests that we are not mere accidents of cosmic evolution, but essential participants in the universe's ongoing process of self-discovery. Every act of observation, every moment of awareness, every choice we make, participates in the grand quantum dance of reality. As our journey through the quantum realm draws toward its close, we carry with us a transformed understanding of what it means to exist. We are quantum beings in a quantum universe, consciousness and cosmos engaged in an eternal dance of observation and creation. The boundary between observer and observed, between mind and matter, between self and universe, reveals itself as a convenient fiction that dissolves in the face of quantum reality. In the end, perhaps the most profound insight from our exploration is this: the universe is not a machine that we observe from the outside, but a living, evolving system that we participate in from within. The quantum realm operates on principles that challenge our everyday understanding of reality. While the classical world appears solid and predictable, the quantum universe reveals a reality that is inherently uncertain, interconnected, and shaped by the very act of observation. This isn't merely a philosophical curiosity. It suggests something profound about the nature of existence itself and our role within it. What we've discovered through quantum mechanics is that at the fundamental level, reality exists in a state of pure possibility until the moment of observation collapses these possibilities into definite outcomes. This phenomenon, known as the observer effect, hints at a universe where consciousness and reality are intimately intertwined. The act of measurement doesn't simply reveal pre-existing properties, it appears to participate in creating them. Consider the implications of quantum entanglement, where particles remain mysteriously connected across vast distances, instantaneously affecting one another regardless of the space between them. This suggests that separation, as we normally conceive it, may be an illusion. At the quantum level, everything appears to be part of an interconnected web of relationships, challenging our classical notions of individual, isolated objects existing independently in space and time. The principle of superposition further complicates our understanding. Quantum systems exist in multiple states simultaneously until observation forces them to choose. This isn't simply a limitation of our knowledge, it appears to be a fundamental feature of reality itself. Before measurement, an electron doesn't have a definite position or spin. It exists in a ghostly combination of all possible states, a phenomenon that defies our classical intuitions about how the world should behave. Yet perhaps the most intriguing aspect of quantum mechanics is how these seemingly bizarre effects scale up into the classical world through a process called decoherence. As quantum systems interact with their environment, the strange superpositions collapse into the familiar, definite states we observe in daily life. But this transition isn't arbitrary. It's governed by the same quantum principles that operate at the smallest scales. Recent discoveries have revealed that quantum effects aren't confined to sterile laboratory conditions or the microscopic realm. They appear to play crucial roles in biological processes that sustain life itself. Photosynthesis, the process that converts sunlight into chemical energy, seems to utilize quantum coherence to achieve near-perfect efficiency. Birds may navigate using quantum entanglement in their magnetic sensors. Even the process of smell might depend on quantum tunneling effects that allow molecules to communicate their properties to our olfactory receptors. These findings suggest that life and consciousness may be deeply rooted in quantum processes, not separate from them. The boundary between the quantum and classical worlds isn't as clear-cut as we once believed. Instead, we appear to exist in a universe where quantum effects bubble up into the macroscopic world, influencing everything from biological systems to potentially consciousness itself. Some researchers propose that consciousness itself might be a quantum phenomenon. While this remains highly speculative, the idea isn't without merit. The hard problem of consciousness, how subjective experience arises from objective matter, has puzzled philosophers and scientists for centuries. Quantum mechanics offers a potential bridge, suggesting that the act of observation, the collapse of possibilities into reality, might be fundamentally tied to conscious awareness. If this is true, then we are not passive observers of a predetermined universe. We are active participants, co-creators, whose very attention helps shape the reality we experience. Every observation, every measurement, every moment of conscious awareness participates in the ongoing creation of the world. This doesn't mean we can bend reality to our will through positive thinking, but it does suggest that the universe is far more participatory and creative than our classical worldview would suggest. The quantum world also reveals time itself as more mysterious than we imagined. Quantum systems can exhibit temporal non-locality, where future events can influence past states. The sequence of cause and effect, so fundamental to our understanding of how things work, becomes ambiguous at the quantum level. Past, present, and future may be more interconnected than we realize, woven together in ways that challenge our linear perception of time's passage. This quantum perspective offers a profound shift in how we understand our place in the cosmos. Rather than being insignificant specks in a vast, indifferent universe, we emerge as conscious participants in an ongoing creative process. The universe isn't a machine running according to predetermined laws. It's a living, evolving system where information, consciousness, and reality are intimately connected. The implications extend beyond physics and philosophy into how we understand meaning, purpose, and connection. In a quantum universe, everything is fundamentally interconnected. The artificial boundaries we draw between self and other, between mind and matter, between observer and observed, may be convenient fictions that help us navigate daily life, but don't reflect the deeper nature of reality. This interconnectedness doesn't eliminate individual agency or reduce everything to a vague, mystical oneness. Instead, it suggests that our choices, our observations, and our consciousness participate in the ongoing creation of reality. We are neither gods who create reality through will alone, nor puppets dancing to the tune of mechanical laws. We are conscious participants in a universe that is creative, responsive, and fundamentally alive. The quantum realm teaches us that uncertainty isn't a bug in the system, it's a feature. The fundamental indeterminacy of quantum mechanics isn't something to be solved or overcome, but something to be embraced as the source of novelty, creativity, and genuine choice in the universe. Without quantum uncertainty, the future would be as fixed as the past, and genuine creativity would be impossible. As we stand at the threshold of deeper quantum understanding, we find ourselves not at the end of mystery, but at its beginning. The more we learn about the quantum nature of reality, the more we realize how much we don't know. But this isn't cause for despair, it's cause for wonder. We live in a universe far stranger, more beautiful, and more participatory than our ancestors could have imagined. The quantum revolution isn't just changing our understanding of physics, it's transforming our understanding of existence itself. We are discovering that we live in a universe where consciousness and reality dance together, where the act of observation participates in creation, and where the fundamental nature of existence is not matter or energy, but information, relationship, and possibility itself. This is the hidden reality of quantum physics, not just a description of how particles behave, but a revelation of how existence itself unfolds moment by moment through the interplay of consciousness, observation, and infinite possibility. The quantum realm exists as a shimmering boundary between the known and unknowable, where the very act of observation transforms reality itself. We've journeyed through superposition and entanglement, witnessed how particles dance in probability clouds until the moment consciousness touches them, and seen how this strange microscopic world might hold the keys to understanding life, mind, and the cosmos itself. What emerges from this exploration is perhaps the most profound revelation in the history of science. We are not separate observers of reality, but active participants in its creation. Every measurement, every observation, every moment of conscious awareness ripples through the quantum field, collapsing possibilities into actualities. The universe, it seems, is not a cold mechanical clockwork, but a living, responsive web of information and consciousness. Consider how this changes everything. The quantum effects we've explored don't simply vanish at larger scales. They scale up through biological systems, neural networks, and perhaps even the fabric of space-time itself. The entanglement that Einstein called spooky action at a distance might be the very mechanism by which consciousness connects to the quantum field. The observer effect that collapses wave functions might be consciousness itself reaching across the void to touch the fundamental structure of reality. This participatory universe challenges our deepest assumptions about objectivity, determinism, and the nature of existence. If quantum mechanics is correct, and the evidence overwhelmingly suggests it is, then reality is far stranger and more wonderful than our classical minds can easily grasp. We live in a cosmos where information is more fundamental than matter, where consciousness plays an active role in shaping what becomes real, and where the boundaries between observer and observed dissolve into quantum foam. The implications stretch far beyond physics. If biological systems harness quantum coherence, if consciousness operates through quantum processes, if the universe itself is a vast information processing system, then we are not isolated beings trapped in separate skulls, but interconnected nodes in a cosmic web of awareness. The mystics may have been right all along. Consciousness and cosmos are one seamless whole, and we are the universe awakening to itself. This quantum perspective offers hope in an age of fragmentation and despair. It suggests that our thoughts, our observations, our very presence in the world matters at the deepest level. We are not powerless spectators of a predetermined reality, but co-creators in an unfolding cosmic story. The quantum field responds to consciousness, entanglement connects all things, and information flows through the very structure of space-time itself. As we stand on the threshold of a new understanding, we face a choice. We can retreat into the comfortable certainties of classical thinking, or we can embrace the magnificent uncertainty of quantum reality. We can see ourselves as separate and isolated, or as part of an interconnected whole. We can view the universe as dead matter in motion, or as a living system of consciousness and information. The quantum realm whispers to us across the scales, from the smallest particles to the largest structures in the cosmos. It tells us that reality is not fixed but fluid, not separate but connected, not dead but vibrantly alive with possibility. In this participatory universe, consciousness is not an accident, but a fundamental feature, not a byproduct, but a creative force, not separate from nature but woven into its very essence. Perhaps this is the ultimate message of quantum physics. We are not strangers in a strange land, but children of the cosmos coming home to ourselves. The universe that gave birth to us continues to shape us, and we in turn shape it through every act of observation, every moment of awareness, every choice we make. In the quantum realm, the observer and the observed dance together in an eternal embrace, creating reality with each step, each breath, each heartbeat. And so we find ourselves not at the end of understanding, but at the beginning of a new kind of knowing. A knowing that embraces mystery without abandoning reason, that honors both the scientific method and the depths of consciousness, that sees the universe not as a problem to be solved, but as a story to be lived. In this quantum cosmos, we are both authors and characters, observers and participants, seekers, and the very thing we seek. The hidden reality of quantum physics reveals itself not as a collection of bizarre phenomena, but as an invitation to participate more fully in the cosmic dance of consciousness and creation. In the quantum realm, consciousness and reality dance together in ways that stretch our understanding far beyond classical physics. As we've journeyed through the mysteries of superposition, entanglement, and the observer effect, we've discovered that quantum mechanics doesn't just describe the behavior of particles. It reveals something profound about the nature of existence itself. The implications are staggering. If consciousness plays a fundamental role in collapsing wave functions, if observation literally shapes reality, then we are not passive observers of the universe, but active participants in its creation. Every measurement, every conscious act of observation becomes a moment of cosmic collaboration between mind and matter. Consider how this changes everything. The quantum field that underlies all reality isn't just a mathematical abstraction. It's a living, breathing foundation of pure potential. Within this field, particles exist in superposition until consciousness intervenes, collapsing infinite possibilities into the singular reality we experience. We are, quite literally, co-creators of the world around us. The quantum entanglement that connects particles across vast distances mirrors something deeper. A fundamental interconnectedness that weaves through the fabric of existence. When two particles become entangled, they share a bond that transcends space and time. Their properties remain correlated no matter how far apart they drift, suggesting that separation itself might be an illusion. At the quantum level, everything is connected to everything else in ways that defy our everyday understanding. This interconnectedness extends far beyond the laboratory. In biological systems, quantum effects orchestrate the miracle of photosynthesis, guide migrating birds across continents, and perhaps even enable the complex computations of consciousness itself. Your brain, that 3-pound universe nestled between your ears, may be running on quantum processes that blur the line between mind and matter, between thought and reality. The implications for consciousness are profound. If microtubules in neurons can maintain quantum coherence, if consciousness emerges from quantum processes, then awareness itself becomes a fundamental feature of the universe. Consciousness isn't just something that evolved accidentally. It's woven into the very structure of reality, a cosmic principle as basic as energy or matter. This quantum view of consciousness suggests that our minds are not isolated islands of awareness, but part of a vast, interconnected web of information and experience. The boundaries between self and other, between mind and world, become fluid. We are not separate from the universe. We are the universe becoming aware of itself. The observer effect takes on new meaning in this context. When we observe quantum systems, we're not just measuring, we're participating in the ongoing creation of reality. Every conscious moment is a quantum event, a collapse of possibilities into actuality. You are not just living in reality, you are continuously creating it through the act of observation. This participatory universe challenges our deepest assumptions about objectivity and determinism. In the quantum realm, the future isn't fixed. It's a landscape of probabilities waiting to be actualized by conscious observation. Free will isn't an illusion. It's the mechanism by which consciousness navigates the quantum field of possibilities. The quantum vacuum itself teems with virtual particles, constantly appearing and disappearing, reminding us that even empty space is alive with potential. Nothing is ever truly empty, truly isolated, truly fixed. Everything is process, relationship, becoming. As we peer deeper into the quantum foundations of reality, we discover that information itself may be more fundamental than matter or energy. The universe begins to look less like a machine and more like a vast information processing system, a cosmic computer running on quantum algorithms that we're only beginning to decipher. The holographic principle suggests that all the information in a volume of space can be encoded on its boundary, hinting that reality itself might be a projection from a more fundamental information structure. We might be living in a holographic universe where every part contains information about the whole. This quantum perspective transforms our understanding of time as well. In the quantum realm, the arrow of time becomes fuzzy. Quantum processes can exhibit time-symmetric behavior. An entanglement creates correlations that seem to transcend temporal boundaries. Past, present, and future become more fluid, more interconnected than classical physics would suggest. The measurement problem in quantum mechanics, why we experience definite outcomes instead of superpositions, remains one of the deepest mysteries in science. But perhaps that's the point. Perhaps consciousness exists precisely to collapse the wave function, to actualize specific realities from the infinite sea of quantum possibilities. Every interpretation of quantum mechanics tells us something profound about the nature of reality. Whether we live in a multiverse of parallel worlds, whether consciousness is fundamental to the universe, whether reality is information all the way down, each possibility expands our conception of what it means to exist. The quantum world is not separate from our everyday experience. It underlies it, enables it, and in many ways defines it. The coherence of your thoughts, the efficiency of photosynthesis, the navigation abilities of birds, the strange correlations that seem to connect distant events. All of these emerge from quantum foundations. As we stand at the threshold of the quantum age, with quantum computers beginning to harness the power of superposition and entanglement, we're not just developing new technology, we're learning to think and create in harmony with the deepest principles of reality. We're becoming quantum natives, learning to work with uncertainty, interconnection, and possibility rather than against them. The quantum universe is not a cold, mechanical system, but a warm, living, responsive reality that seems almost designed for consciousness. It's a universe where observation matters, where consciousness plays a role, where everything is connected to everything else in ways that suggest a deeper unity underlying the apparent diversity of experience. Perhaps most remarkably, quantum mechanics suggests that the universe is fundamentally creative. At every moment, quantum processes are generating new possibilities, new configurations, new ways for reality to unfold. We live in a universe that is not just evolving, but actively creating itself, moment by moment, observation by observation. This is the hidden reality of quantum physics, not just a theory about particles and waves, but a revelation about the nature of existence itself. We are not separate from the cosmos, but intimately connected to it, not passive observers, but active participants in the ongoing creation of reality. The quantum universe invites us to embrace mystery, to find meaning in uncertainty, to see connection where classical physics sees separation. It suggests that consciousness and cosmos are not two separate things, but aspects of a single, unified reality that we are only beginning to understand. As you drift off to sleep tonight, remember that you are not just a collection of atoms and molecules. You are a conscious being in a quantum universe, a point of awareness in an infinite field of possibilities. Your thoughts, your observations, your very existence participates in the cosmic dance of consciousness and reality. The quantum realm doesn't diminish the mystery of existence. It deepens it. It doesn't reduce consciousness to mere computation. It elevates it to a cosmic principle. It doesn't separate mind from matter. It reveals their fundamental unity. In the end, the hidden reality of quantum physics is not hidden at all. It's the most intimate reality we know, the reality of consciousness itself, the reality of connection, the reality of a universe that seems to know we're here and to care about our observations. We are quantum beings in a quantum cosmos, forever entangled with the mystery of existence itself. Sweet dreams, fellow quantum travelers. May your rest be filled with the gentle hum of uncertainty, the warm embrace of interconnection, and the infinite possibilities that await each new moment of conscious observation. The universe is dreaming, and we are both the dreamers and the dream.